We now discuss examples based on addition formulas. So here see the first question. Evaluate the following. The first one is here. We are having cosine 135 degree. Now what we do, we express 135 as a plus or minus of this reference point. You know, here 0, here 90, here 180, here 3 pi by 2, that is 270, and so on. So this is pi by 2, this is 0, 2 pi, and so on. Positive anti-clockwise, negative clockwise. This is negative, this is positive. So I'll rewrite like this. Cosine 135, one way is you can write 90 plus 45. Now you know here 90, as we were discussed earlier, 90 plus something, 90 is here, plus some angle alpha. So this will be in second quadrant. In the second quadrant, cos is negative, so your answer will be in minus. And you have 90, therefore it would be sine 45, remember. Why sine function? If you remember, if you have pi by 2, 3 pi by 2, 5 pi by 2, then cos becomes sine and this angle. Now, why minus sign? Because cosine in the second quadrant, this all STC. In the second quadrant, cos is negative, minus cos becomes sine. Now sine 45, which is 1 by root 2. So answer is minus 1 upon root 2. Or you could have done like this also. Cosine 135, you can write, always you write plus or minus of these 4 standard reference points, remember. So I can write cosine 180 minus how much? So this is again minus 45. Now this is pi minus something. Here you have pi or 180 minus something, that is clockwise. So again second quadrant, this will be in the second quadrant. In the second quadrant, cos is negative, minus, and pi is there, so cos remains same, so cosine 45. So again minus 1 by root 2. Your answer is same, remember, whether you do 180 minus 45 or 90 plus 45. Whichever way you like, you can do it. Suppose next, I have 10 minus 23 pi by 6, for example. Now you know that 10 is an odd function, so this minus sign will come out. Minus 10, 23 pi by 6, if you remember, 10 of minus x equals to minus 10x. Odd function, if you remember. Okay, now we keep this minus as it is, this one as it is. You know how to do this. Find the multiple of 6 close to 23, which is 24 by 6. So you can write 4 pi minus pi by 6. Right? This we did earlier, this arrangement. 4 pi minus pi by 6, 24 minus 123. Now here, this minus sign as it is. 4 pi, it is here. That is same as 0, 4 pi, 2 pi. 4 pi is here. Minus something. Minus means clockwise. So it will be here in the fourth quadrant. What happens in the fourth quadrant? 10 is positive or negative? All STC. So here 10 is negative. So one more minus sign. And pi is there, so 10 remains same. So 10 pi by 6. This minus sign you are not going to take here, remember. So this will be, 10, this is just 10 pi by 6. 10 pi by 6 is 1 by root 3. This is the value. One more, let's write sec 690. Now we did earlier number of times such things. 690 is very close to 720. 3 pi 6 360, 4 pi 720. Right? So 690 is close to 720. So how do I rewrite? 720 minus 30 degree. 30 degree is the standard value. 720 is 4 pi. Where is 4 pi? Again here. Minus something. So it will be in which quadrant? Fourth quadrant. In the fourth quadrant, sec is positive. C means cos and sec. Both are positive. And this is 4 pi. So function remains same. So this is sec 30 degree. Now you know the value of this. At least cos 30 you know. What is cos 30? That is the root 3 by 2. This much you know. So this will be 2 by root 3. This is the value. So next I want to show that this expression equals to 1. So in the solution I'll start with LHS here. Left hand side. You can copy this entire expression here. This is equals to. I'll write directly your values. Okay. Now come to this. This much you can copy here on the left hand side. Here, directly value of this sine of minus theta. Sine is an odd function. So minus sine theta into pi by 2 minus theta. Here pi by 2 minus first quadrant. In the first quadrant all trigonometric functions are positive, but because of pi by 2 you will get cot theta here. Pi minus theta, pi is here. Minus means second quadrant. Minus means you are moving in clockwise, remember. Minus means this will be in the second quadrant. And the second quadrant all s, so sine is positive. So this will be just sine theta, and sine function will be there because you have pi. Into 3 pi by 2 plus theta. 3 pi by 2 is here, this is 3 pi by 2. Plus theta means you are moving in anti-clockwise direction. Plus means in this direction. You will be in which quadrant? Fourth quadrant. In the fourth quadrant, sec is positive. All S, T, C. Cos and sec are positive, here. So this will be positive, but because of pi by 2, you will get the corresponding function. So cosec theta. Come to this now. Pi plus theta. Pi is somewhere here. Plus means third quadrant. In the third quadrant, sine is negative, and sine will be there because you have pi. So minus sine theta. Pi plus means third quadrant here. So sine is negative. 3 pi by 2 minus theta. 3 pi by 2 is here. Minus means clockwise. So this will be in which quadrant? Third quadrant. In the third quadrant, cos is negative. So you have minus, but 3 pi by 2 is there. So you will get the minus sine theta corresponding function. Angle is this. Pi minus theta. Pi is here. Minus means second quadrant. There cosec is positive because in the second quadrant sine and cosec both are positive, and pi therefore function remains same. So cosec theta. Come to this now. 2 pi minus theta. 2 pi is here. Minus means in clockwise direction. So this will be in fourth quadrant. In the fourth quadrant, what about cot? Cot is negative. So minus cot theta. Now you will see that 1, 2, 3, 4. So our minus sign will get cancelled. Cot will get cancelled. Sine will get cancelled. Cosec will get cancelled. Sine will get cancelled. So this is 1. This is RHS. Now next here, suppose third question, prove that here sec square 129 degree minus cosec square 31 degree upon cosec 39 degree minus sec 121 degree equals to, you want to prove this, cosec 39 minus sec 59. We want to prove this. So in the solution, we start with LHS here, left hand side. So what is left hand side? That is sec square 129 minus cosec square 31 degree upon cosec 39 degree minus sec 121 degree. Okay. Now we concentrate on RHS. We need 39 and 59, remember. So we try to set every angle in this form, 39 and 59. Fine. So here we write sec square. This you can write 90 plus 39. So this is 129 minus cosec square function as it is 31. You can write 90 minus 59. So this would be 31 here. Instead of 90, 31, what I did, I wrote 90 minus 59. So I'll get 31 upon, here we need 39, so we keep this one as it is, minus, how do we express 21? That we write as 90 plus here 31. So here if I write 90 plus 31, but you don't want 31, I need 59. So what I'll do, instead of this, I'll write 180 minus 59. So you will get 121, right? We just set according to RHS. Now we use the concept of quadrant. 90 plus something, 90 is here. Second quadrant. In the second quadrant, being square here, positive, negative is not important, but 90 is there, so this become cosec square 39 degree. Why plus minus is not important? Because you have square. 90 minus something, so it will be in first quadrant. There all are positive, but 90 is there. 90 means pi by 2. So corresponding function sec square 59 degree upon this one as it is, minus 180 minus something. 180 means pi here. Minus means second quadrant, clockwise. In the second quadrant, sec is negative. So here it will be one more minus sign, so this become plus, and sec would be as it is because you have pi. This is pi, multiple of pi. So sec 59 degree. Now you see this looks like a square minus b square upon a plus b. So numerator has two factor. Sec cosec 39 minus sec 59 into cosec 39 plus sec 59 upon cosec 39 plus sec 59. So that plus factor will get cancelled. You will get just this much only, and that is RHS. So next question is, we want to get the values of sin pi by 12, cos pi by 12, tan pi by 12 and cot pi by 12. Pi by 12, that's the radian measure, which is same as 15 degree. So this is as good as sine 15 degree. Similarly, cosine 15 degree and so on. So in the solution, we'll do this way. We use the addition formulas here. Sine pi by 12 or sine 15 degree. You just reduce 15 into radian, you will get this. Now how we'll do? We express this 15 degree as a difference of two known values. So you can write 45 minus 30. That is same as this sine pi by 4 minus, I think, pi by 6. If you take LCM, you will get exactly pi by 12. Now I'll expand this by addition formula. This is like x and this is like y. So sine x into cos y minus cos x into sine y. Addition formula. This is like x and this is like y. Sine x into cos y minus cos x into sine y. Now each of these you know. What is sine 45? 1 by root 2. What is cos 30? You know, root 3 by 2. What is cosine 45? 1 by root 2. What is sine 30? You know, 1 by 2. So here root 3 minus 1 upon 2 root 2. If you want to just rationalize, multiplying and dividing by root 2 you can do here. So this is root 6 minus root 2. Root 2 gives us 2. So 2 into 2, 4. So this is the value of sine 15 degree. Same way you can go for cosine 15 degree. Cosine pi by 12. That is cosine 15 degree. That is cosine 45 minus 30 degree. You can use again addition formula. Cos x into cos y plus opposite sign. For cos function your opposite sign plus sin x into sin 45. Sin x into sin y, so 30 degree. Now just put the values. Cos 45 1 by root 2. Cos 30 root 3 by 2. Sin 45 1 by root 2. Cos sin 30 1 by 2. So we'll get the root 3 plus 1 upon 2 root 2. So here, if I just rationalize this, you know, such things, multiply and dividing by root 2. If you want, you can keep this one also, but normally if we have irrational number, we rationalize. Now I'll open the bracket here. So root 6 plus root 2. Root 2 gives you 2. 2 into 2, 4. So this is the value of cosine 15 degree. Okay, now next we go to 10. Next we go to 10 pi by 12. So let's go for that. So 10 pi by 12, that is same as 10 15 degree. I'll use addition formula for 10 here. So you can write 10 45 minus 10 30. Right? Now we expand by addition formula for 10, you know, 10 of x minus y, which is 10x minus 10y upon 1 plus 10x into 10y, if you remember. Now just put the values, you know, 10 45 1. Here you know this is nothing but 1 by root 3 upon 1 plus 1 by root 3. So just simplify now. So root 3 minus 1 upon root 3 plus 1. Taking LCM here, and root 3 will get cancelled. Again we have irrational number here, so we rationalize, multiplying and dividing with its conjugate, you know this. Such things, rationalization, you know. Multiplying and dividing with this. So what we'll get here? This is a plus b, a minus b. So a square minus b square. Root 3 whole square. 3 minus 1. You have used this. A minus b into a plus b, which is a square minus b square. Root 3 square, which is 3, 1 square. What about this? This is root 3 minus 1, the whole square. So finally it is upon 2. What about this? If you open the bracket, a square plus b square. So 3 plus 1 minus 2 root 3. So this is 4 minus 2 root 3 by 2. So 1, 2 will get cancelled. This is 10 pi by 12. So 10 pi by 12 equals to 2 minus root 3. This is your value. Same way you can try for fourth one. Sorry, this was third one. Now here this is fourth one. Fourth one is value of cot pi by 12. So same way you can just expand it, and it would be just 2 plus root 3. You can verify. Right? This for you try. Use the formula for cot function. Fine. Now your next question is, let's see, suppose I want to get the value of here. Next question is, you are given cos A 1 by 7, cos B 13 by 14. A and B both are in first quadrant. Prove that A minus B equals to pi by 3. So here what I'll do, for example, I'll show that here sine of, you imagine this is like alpha. So if I show like this, like sine of A minus B equals to, if I prove for example root 3 by 2, then this must be pi by 3. Right? That you know. So I'll start with this. I'll use addition formula. I'll put all the values and I'll try to show this. If I can show that the sine of some angle equals to root 3 by 2, then A minus B has to be, this angle has to be, you know, this sine pi by 3 is root 3 by 2. This you know. Right? So this is like A minus B here. Fine. So I'll start with sine A minus B. So let me start with sine A minus B here. You know addition formula for sine. Sine x into cos y minus cos x into sine y. Sine x into cos y minus cos x into sine y. Okay. Now these two values you have, cos A and cos B. We don't have these two. So we use these two. Cos A equals to 1 by 7. So we'll get the sine A here. How do we get this? You can use this identity, you know. Sine square A equals to 1 minus cos square A. You can use this. So this will be just 1 minus 1 by 49 here. So this would be 48 by 49. So if I take the square root here, or let me write here 48 by 49. So therefore what is sine A from this? Root of 48 and root of 49, which is 7, and square root of 48. What's the square root of 48? You know it is 4 root 3. That you know, it's like root 48, which is 16 will come out, so it will be 4 root 3. This much you know. Okay. And why this is positive? Because here you look at the question, A and B both are in first quadrant. Their all trigonometric functions are positive. Now go to cos B. What is cosine B? 13 by 14. So again use the same identity. So sine square B equals to 1 minus 169 by 196. So here how do we simplify this? So sine B square equals to 27 by 196. So sine B equals to here root 26. This is 14. So root 26, you know, it will be 3 root 3. Root 27 equals to 3 root 3, that you know. So we have this. This is again positive. Why it is positive? Because B is in the first quadrant. That's given to you, first quadrant. Okay, now we put all these values 1, 2, 3 and 4 on the left hand side. So sine of A minus B equals to sine A. What is sine A? 4 root 3 by 7 into cos B. What is cos B? 13 by 14 minus cos A. What is cos A? 1 by 7. And what is sine B? 3 root 3 by 14. So here the LCM will be 7 into 14. You will have here this is 52 root 3 minus 3 root 3. So this is 49 into root 3 by 7 into 14. So this is 7 there. So finally you can see that this is just root 3 by 2. So sine of A minus B equals to root 3 by 2. That's what we wanted in the beginning, if you remember. So therefore A minus B has to be pi by 3. Right? This is your answer, because you know sine pi by 3 equals to root 3 by 2. So this has to be pi by 3. So your next question is, you are given here sine A equals to 1 by root 5, cosine B equals to 3 by root 10. A and B both are from 0 to pi by 2. That is the first quadrant, remember. Then you are asked to prove that it's like previous question. A plus B equals to pi by 4. I repeat, sine A equals to 1 by root 5, cos B 3 by root 10. Then you show that A plus B both are in first quadrant. So how we'll do this? You know here you want to show that this angle equals to pi by 4, that is 45 degrees. So just to prove, for example, cos of A plus B equals to 1 by root 2. Prove this. If I show this, then you can say that this has to be pi by 4. Right? So this I leave it for you, like previous question. Try. What you will do here? You will start with cos A plus B. Use addition formula. Use addition formula here. And put all respective values. Sin A you have, therefore you can get the cos A. Sin cos B you have, therefore you can get the sin B. And hence you can find. Okay. Now next we have, next question is, prove that tan pi by 3 minus alpha equals to root 3 cosine alpha minus sin alpha upon cos alpha plus root 3 sin alpha. Okay, we want to prove this. So in the solution, I'll start with LHS, left hand side here. So what is LHS? That is tan pi by 3 minus alpha. You must have realized this just addition formula for tan. So tan pi by 3 minus tan alpha, tan x minus tan y upon 1 plus tan x into tan y. Addition formula for tan. Now on the right hand side you see you need everything in sin cos. So I'll just reduce into sin cos. What is tan pi by 3? You know root 3 minus sin alpha upon cos alpha 1 plus, what is tan pi by 4? Root 3 into sin alpha upon cosine alpha. Just take the LCM. So root 3 cos alpha minus sin alpha upon cos alpha plus root 3 sin alpha. This is what your RHS. We have just used the addition formula for tan. Here remember, you cannot use that pi by 3 minus something is first or second quadrant, because pi by 3 is not one of these 4 points. That concept of the quadrant is useful only when you have one of the 4 points. So that concept cannot be used here. 8th question, that I leave it for you. Prove that tan 39 degree equals to root 3 cos 21 degree minus sin 21 degree upon cos 21 degree plus root 3 sin 21 degree. So try, start with LHS. How we'll do this? Here you start with LHS. Tan 39 degree, you try to express tan 39 in form of, on the right hand side you want 21, so I'll put 21. Now you think here what should be placed, and then use addition formula, so we'll get RHS. So now next question is, you are asked to prove that tan 3a, tan 2a, tan a equals to this. Nothing is given. So what we notice from the question is, there are 3 angles, 3a, 2a and a. So we write a plus 2a equals to 3a. Right here we have just observed from the question. Now I'll apply tan on both the sides. So tan a plus 2a equals to tan 3a. Just applying tan on both the sides. Applying tan. Now on the left hand side you can see that addition formula. This tan 3a as it is. What is left hand side? That is tan a plus tan 2a upon 1 minus tan a into tan 2a. X plus y. So sum is now almost over. You take this one over here. So tan a plus tan 2a equals to tan 3a 1 minus tan a into tan 2a. Just now open the bracket and simplify, so you'll get exactly what you want. This one plus tan 2a, if I open the bracket here, tan 3a minus product of these 3, tan a into tan 2a into tan 3a. Now I'll take this term on the left hand side and these 2 term on RHS, taking this one on the left hand side. So tan a into tan 2a into tan 3a equals to this one as it is, tan 3a. These 2 terms I'll take on the right hand side. So minus tan a minus tan 2a. So that's what you want, entire expression. The next question, try yourselves. 10th question, prove that tan 25 degree into tan 15 degree plus tan 15 degree into tan 50 degree plus tan 25 degree into tan 50 degree equals to 1. Now here also I'll not do the entire solution, I'll just give the hint. There are one 25 degree if you observe, the other one 15 degree and one more 50 degree. These are the 3 different angles. So here if we notice 15 degree plus 25 degree plus 50 degree. If you observe this 3, which is nothing but 90. Now you keep 2 as it is, because for 3 alpha beta you don't have addition formula. So I'll keep this one as it is. 15 and 25 as it is. This is 90 minus 50. don't write 90 minus 50 as 40 because you want 50. And now you apply tan on both the sides. So tan 15 degree, tan 20, here bracket 25 degree. This is tan 90 minus 50. Don't try it as a 40 because you don't want 40 here. Now use addition formula here. 90 minus something here. So first quadrant. In first quadrant all are positive. So this become cot. Why cot? Because 90. Cot 50. You write here 1 upon tan 50. And use addition formula and just simplify. So you'll get exactly this expression. The next question, you are given a plus b is pi by 4. Two sub question. First, to show that this is 2, the similar formula for cot function. So I'll do one for you. Here you are given a plus b equals to pi by 4. So that's given. Here if I look at it, LHS 1 plus tan a into 1 plus tan b. Now you can reduce into same angle. So what we'll do, we put the value of b, for example. You can put the value of a also. So this is 10. What is b from this? B is nothing but the pi by 4 minus a. So this is pi by 4 minus a. This one as it is 1 plus tan a. 1 plus as it is. Here we use addition formula for tan. Tan a minus tan b upon 1 plus that formula. So tan 45, which I'll write 1 directly, minus tan a upon 1 plus tan 45, which I'll write 1 into tan b, which is tan a. What I did here, instead of b I placed pi by 4 minus a. So the entire question is now is in a. You can have done a equals to pi by 4 minus b. That is not important. So 1 plus tan a here. Take LCM here. This is 1 plus tan a. So 1 plus tan a plus 1 minus tan a upon 1 plus tan a. This will get cancelled here. 1 plus 1 is 2. This will get cancelled. Here 1 and 1 gives us 2, which is RHS. Same way you can go to second sub question. Try this for you. Same way, there you are going to use the formula for cot function. Now I'll state some 2 more formulas based on addition rule only. One is this, cos of x plus y into cosine of x minus y. One formula for this, and the other one, that is here, sine of x plus y into sine of x minus y. We'll use this later on. Now this is given by sine square x minus sine square y, remember. How do we prove? Proof is very simple. Just to expand this and simplify, you'll get exactly this. Sine of x plus y into sine of x minus y is sine square x minus sine square y. Same formula for cos function. Here this is cos square x minus sine square y, remember. This is in mixed function on RHS. Here when we have cos of x into y, x plus y into cos of x minus y, then this is cos square x minus sine square y, remember. Cos and sine in the formula of cos function. In the formula of sine, both are sine functions here, cos and sine. For example, if I want to get this value, like let's write sine square 37.5 minus sine square 7.5. Suppose I want this. So look at this RHS, it is exactly this. This is like x, this is like y. So instead of this, I can write sine x plus y. So 37.5 plus 7.5 into sine 37.5 minus 7.5. What I did, I've used this. This is given to you. I wrote this x plus y. So 37.5 plus 7.5 into 37.5 minus 7.5. What is this? This 45 degree. What is this? This 37.5 minus 7.5, which is 30 degree. This is 1 by root 2. This is 1 by 2. So your final answer is 1 upon 2 root 2. That's one. Second one. Now next, suppose I want to get this sine square 52.5 minus cos square 7.5. Now this is about cos and sine. So look at this. So I need cos first and then sine. So I'll take minus common. So cos square 7.5 minus sine square 52.5. So now this is exactly same as this expression. So this would be cos x plus y into cos x minus y. So cosine this plus this 7.5 plus 52.5 into cosine 7.5 minus 52.5. Now what is this? This is nothing but the cosine 60 degree. 52.5 plus 7.5 into cosine, what is this? Minus 45 degree. Minus cos 60, that is 1 by 2. Cos is an even function, so this is same as cos 45 degree. Remember, cos minus 45 degree, it is same as cos 45 degree. It's an even function, And what is cos 45 degree? 1 by root 2. So this is minus 1 upon 2 root 2 is the answer. So this way we use these two important formulas, remember. The next is here range of before I state this, for example, if you have cos x function, what's the range of cos x? Minus 1 to 1, If I have 2 cos x, then what would be the range? It would be obviously minus 2 to 2, right? Range means, these are the range. Range means, maximum and minimum value. For example, what's the range of sine function? Maximum 1, minimum minus 1. So what's the range of, for example, 3 sine x? So maximum will be 3 multiplying with 3 and minimum will be minus 3. So range would be minus 3 to 3. This much we know. But now we have mixed function of this type here. That is, we have a cos x plus b sine x, such function. Range of a cos x plus b sine x, such mixed function. Not cosine alone, not sine alone. A and b be some constant, where a and b be some constants. These are the constant. So range of a cos x plus b sin x is given by closed interval minus r2 plus r, where what is r? R is given by root of a square plus b square. Without proof, I'm stating. What's the range of a cos x plus b sin x? That's minus r2 plus r. Maximum value is r of this function and minimum value of this function is minus r, where what is r? That is root of a square plus b square. A means coefficient of cos and b means coefficient of sine. Okay. So now suppose question is here, for example, find range of this function, range of cos x plus sin x, for example, this function, mixed function. So how we'll do this? Range means what's the maximum value of this function and minimum value of this function. So if I compare these two, here a is 1, b is also 1. So it implies what is r, that is root of a square plus b square, that is root 2. So therefore you can say that range would be minus root 2 plus root 2. That is what I'm trying to tell you is cos x plus sin x, the maximum is root 2 and minimum is minus root 2, remember, like this. So this is a minimum value and this is maximum value, maximum and minimum value of a function. Next, one more example. Let's see. Question is find the range of let me write 7 sin theta plus 24 cosine theta. Let's do this mixed function. So if you just recall, your a is 24, b is 7 here. So what would be r here? That is a square plus b square, 24 plus 7 square. You know this is just 625, so this is 25. So therefore what is range? Range would be, so this is the range, minus r to plus r, that is minus 25 to plus 25.